Hello students, myself Professor Ankur. I welcome everyone for the GATE Sum session on analog circuits. Today we are going to discuss important sums on negative feedback. This is the first session on negative feedback. Let's start with the session. So let's take the first question. The question is, the gain of the amplifier without feedback is 50. However, due to aging, it falls to 40. When the gain without feedback was 50, the gain with negative feedback was 25. Now the gain without feedback falls to 40. Find percentage reduction in stage gain. Or the question is, percentage reduction in stage gain is. So here we are actually given two situations. The first situation was a simple amplifier with a gain of 50, and due to the effect of aging, the gain went to a value 40. So this is the first thing we can calculate, that due to the effect of aging, what's a change in the stage gain. So the first part of the solution is we are trying to solve without feedback. So the AV value, old value was 50. The new value became 40. So if I want to get the percentage change, I will have to go for change, that is 50 minus 40 upon the old value, that is 50 into 100. I can see a 20% change of gain. Now comes the second situation where the gain without feedback was 50, but with feedback the gain became 25. So now we have a standard relation, gain with feedback AF is equal to A by 1 plus A beta. Using that logic, so if I try to solve, AVF is equal to AV by 1 plus AV beta. So the gain with feedback is 25. The original gain was 50. So I'll get 25 is equal to 50 divided by 1 plus 50 beta. So automatically I will get AV beta equal to 1, and you will get beta equal to 1 by 50. So now the question is regarding the second part. So when you see the question carefully, it says when the gain without feedback was 50, the gain with negative feedback was 25. So the open loop gain was 50, and with the feedback it became 25. But suddenly now the gain without feedback falls to 40. So it's as good as the amplifier gain has fallen to 40. So let's check what's the impact on the gain with feedback. So you're trying to calculate the gain with feedback. So now if I want to calculate the gain with feedback, it will be 40 upon 1 plus 40 into 1 by 50. Gain upon 1 plus gain beta. So I got the new value of feedback gain as 22.5. The earlier value of feedback gain was actually 25. So now I am trying to get the change. It will be 25 minus 22 by 5 upon 25 into 100. I am getting 11.2. So this is the impact. Next question. The feedback amplifier shown in the figure has four options: current series feedback, voltage series feedback, voltage shunt feedback, and current shunt feedback. Along with the impact of feedback type, they are also discussing the input impedance and the output impedance changes. So this is a circuitry given to us, and we are trying to identify what's the type of feedback. Let's start with the solution. So here if you observe, I can clearly see that VO node and the VF value are actually same. The feedback is taken at the output node, and now I can see VF is equal to VO. So what of this? It is voltage sampling. I can also see a node on the input path, implies it's going to be shunt mixing. So from this entire logic, we came to an understanding that we are having voltage sampling and shunt mixing. So with that concept, I can easily say that this is basically a voltage shunt feedback amplifier circuitry. So the correct answer for this question is option C, voltage shunt feedback with low input impedance and low output impedance. Next question. The question is, Negative feedback in amplifier, there are four options given. Improves the signal to noise ratio at input, improves the signal to noise ratio at output, does not affect the signal to noise ratio at the output, reduces distortion. So we are aware regarding a property of the feedback circuitry that the closed loop gain is basically gain upon 1 plus gain beta. So when we talk about the sensitivity impact and the desensitivity impact, we can easily understand that whenever you try to differentiate the gain with respect to the change, you will get a relation. So if you see, if I try to get the change in the feedback gain with respect to the feedback gain, and when I take a ratio with respect to the change in the original gain with respect to the gain value, we are actually trying to see how much is the impact of change on the new gain when you compare it with respect to the original. So the impact is 1 upon 1 plus A beta. So this concept is defined as sensitivity. So when I take the inverse of that, it is going to be 1 plus A beta. That is what you mean by desensitivity. So desensitivity actually signifies the ability of the system to eliminate few things. So few things are like noises. So automatically if I'm trying to eliminate impact of noises, definitely there will be less distortion in the output. And that's the reason the correct answer is option D. As negative feedback desensitivity increases, hence the impact of variation in the output decreases, leading to reduction in the distortion of the output. Hence the answer is option D. Thank you.